Today we will discuss geometrical optics, which is also called paraxial optics. Paraxial optics means rays which are parallel to principal axis in ideal cases. If it deviate, as in figure, if it deviate from principal axis, then it looks like this. The angle between principal axis and the deviated ray is minimum, which is less than 5 degree. So in paraxial optics we take sin alpha is equals to alpha, which means if alpha is minimum, then sin alpha is equal to alpha, as we know from trigonometry. Tan alpha is equal to approximately equal to alpha, and cos alpha is 1 when angle is infinite small. Now first of all we discuss Fermat's principle. What is Fermat's principle? According to this, a ray of light starting from a point, say A, reaching to another point which is called B by any number of reflection or refraction, then the path chosen by this ray of light is extremum, which means the path could be minimum, could be maximum, or could be stationary. So if we discuss this, then optical path is equals to mu into ds, which means mu is the refractive index of this medium in which the wave propagates, and ds is the displacement. Here displacement is A and B. So if we calculate whole optical path from A to B, then we can integrate this, and by variational principle we know that delta of this whole optical path is equals to 0, which means change in this will be 0. Now law of reflection. We calculate law of reflection formula by using Fermat's principle. In this is the plane. Above that there is one medium, and below that above another medium. Since in the case of reflection, the incident rays reflected back in the same medium, so the refractive index will be same. If the refractive index is same, then the medium is called homogeneous. If there are two different medii of refractive index mu1 and mu2, as in the case of refraction, that medium will be called inhomogeneous. But here is the case of homogeneous medium, which means in all area the refractive index is same and it is equal to mu. So if AP is incident ray and BP is reflected rays, here this is normal to this plane, and I is the angle of incidence I, and R is the angle of reflection. Here we note that these angles I and R is considered with respect to normal always. So if A here this B can be governed by incident rays, which means if we establish a relation between I and R, then by choosing I we can find a different R. So if X is equals to X is distance between A and normal, and L minus X is the distance between normal and B. The distance between A and B will be L. So optical path as we know is equals to mu and ds, which means refractive index plus path. So mu into AB plus B into PB. So mu, as we know, trigonometric function, mu is equals to S is equals to mu into h square plus x square और इसका under root. Similarly, this can be written as in this triangle. So angle of incidence can be determined by x. So optical path Sx is the function of x. Hundreds of such paths are allowed, but the optical path will be extremum, for which the path chosen by ray is maxima, minima or stationary. In other words, the actual path will be that for which optical path is optimum, which means it can be maximum, it can be minimum or stationary, and this can be calculated by the Fermat principle, and in this case that first derivation of this optical path should be equals to 0. So if we differentiate it with respect to x, then we calculate this one after differentiating this with respect to x. Now solving this, since mu cannot be 0, so this should be equal to this, and this is from figure sin I, which means sin I is equals to x upon h square upon x square. Similarly, sin R is equals to L minus x upon under root h square plus L minus x. This can be written as sin I is equals to sin R, which means the angle of I and R is equals. This is called law of reflection.